Hello, my name is Eamon Bauman. I'm a field engineer here with SUSE, formerly Rancher Labs. Welcome to BP 1153, running Rancher on EKS, AKS, and GKE, or running Rancher on hosted Kubernetes clusters. We have a brief agenda today. We're going to go through the history of Rancher hosting prior to version 2.5, which as of this presentation is the latest version. We will then go through the changes present in version 2.5 and then explore some basic considerations for hosting Rancher on a hosted cloud provider platform. Once we cover that, we'll get into some specifics with regard to various cloud providers and considerations one needs to take into account when hosting Rancher on a hosted Kubernetes solution. Starting with the history of Rancher hosting. Now we're talking Rancher versions prior to version 2.5. Again, that is the current present version of Rancher as of this presentation. Prior to version 2.5, RKE, or the Rancher Kubernetes engine, was originally a hard requirement, meaning that if you wanted to run Rancher on a Kubernetes cluster, you needed to host that Kubernetes cluster, or rather, the distribution of that cluster needed to be RKE. In 2019, that requirement evolved to include K3S, and then in 2020, it evolved to include RKE2. RKE, or the Rancher Kubernetes engine, is a Docker-powered distribution of Kubernetes for the data center. RKE is, or was at that point, Rancher's initial distribution of Kubernetes. Based on Docker, it takes upstream Hypercube components from the Kubernetes project and packages them alongside Rancher components for ease of deployment and management. All of the components in an RKE cluster are container-based. So the API server, the controller scheduler, the kube scheduler, the controller manager are all running inside of Docker containers. Another important point for RKE is that direct management of etcd is possible. In contrast to other distributions such as EKS or AKS, you cannot manage etcd on those distributions. An important component of backing up Rancher was the direct ability to manage etcd on an RKE cluster. RKE also uses the RKE command line tool for installation and management. So when setting up an RKE cluster, one was able to execute RKE up on the command line, and the cluster would come into existence according to the configuration options presented. K3S, or 5 less than Kates, is a single binary, optional etcd, simple launched, secure and sane, with minimal dependencies, distribution of Kubernetes. It's a highly available certified distribution designed for production workloads in unattended, resource-constrained, remote locations, or even inside IoT appliances. This distribution came out from Rancher Labs in 2019 and was immediately well regarded as a solution for running Kubernetes in resource-constrained environments. Packaged as a single binary less than 40 megabytes in size, K3S is able to break up the Kubernetes traditional concepts of nodes into two different types, server and agent. If you're familiar with Kubernetes, you'll know that there are typically 3 node types, etcd, control plane, and worker nodes. In a simplified K3S distribution, however, the server and agent node roles make it easier to run these components without having to worry about clustering of etcd and setting up of the various node roles. K3S includes the container runtime, which is containerd, and also adds support for ARM CPU architecture. If you wish, K3S can do away with etcd and use SQL. etcd, however, is the default and will remain available through the lifetime of K3S. In 2020, Rancher introduced RKE2, a secure, compliant Kubernetes distribution. RKE2 focuses on FIPS compliance, supporting SE Linux, and making sure the Kubernetes is securely built for government and secure workloads. RKE2, also known as RKE Government, is Rancher's next-generation Kubernetes distribution. It is a fully CNCF conformant Kubernetes distribution that focuses on security and compliance within the U.S. federal government sector. Important points about RKE2, it provides defaults and configuration options that allow clusters to pass the CIS Kubernetes benchmark with minimal operator intervention. I use the term operator here to mean administrator or SRE, for example, instead of the more traditional Kubernetes controller or operator. RKE2 enables FIPS 140-2 compliance. It supports SE Linux policies and multi-category security or MCS label enforcement. And RKE2's build pipeline regularly scans the components for CVEs, utilizing Trivy to secure the source of the components. Prior to version 2.5, as I've mentioned before, there was the hard requirement on using one of the distributions that we just mentioned. So what was preventing using one of those hosted distributions? Well, backup and restore of Rancher itself was limited to etcd snapshots until version 2.5. In RKE, RKE2, and K3S, there exist mechanisms to take etcd snapshots. Any other distros are not officially supported, even if they had etcd snapshot capability. For example, kubeadm is able to build etcd clusters that can directly be managed. However, we can't guarantee, as Rancher Labs building Rancher, that all other clusters will have etcd manageability enabled. In version 2.5, as we'll get into, we've eliminated this requirement, and now Rancher is able to be run on hosted Kubernetes clusters. Rancher version 2.5. The Rancher backup operator makes its entrance. In Rancher version 2.5, there are a few different large features that were brought into scope. A new user interface has been introduced in version 2.5 called the Cluster Explorer. This is in contrast to the version 2.4 and earlier user interface called the Cluster Manager. There are now new version 2 features for things such as logging and monitoring, and others such as Istio introduced in version 2.5. V2.5 also introduced Fleet, which is a technology for continuous delivery / GitOps at scale. We've introduced enhanced EKS lifecycle management in version 2.5 with the ability to adopt existing EKS clusters into a Rancher installation. And most importantly for this presentation, version 2.5 introduced the Rancher backup and restore operator. The Rancher backup and restore operator is not reliant on etcd. It directly backs up manifests of objects in the cluster. Currently, this is only supported in the local cluster or the Rancher cluster, or excuse me, the Kubernetes cluster in which Rancher is running. This operator is theoretically capable of backing up all Kubernetes resources, but currently in that local cluster, it only targets Rancher-related resources. The importance of developing the Rancher backup and restore operator is underscored in comparison to other backup tools. Other backup tools that shall remain nameless don't necessarily back up the object dependencies between resources in a cluster. For example, let's consider the cluster resource in Rancher. I create a cluster, and that cluster has one or more nodes that belong to it. These are represented as objects inside of the Rancher cluster and stored as custom resources. With that custom resource storage, there are ownership relations that are established on these resources between the instances. For example, if I have a cluster resource, the nodes will be owned by that cluster resource. Certain backup tools did not take into account these ownership components, and so when backing up and restoring these resources, the ownership or the parent-child representation was lost. The Rancher backup and restore operator makes sure that those ownership relations stay intact, as well as any other metadata, annotations, labels, identifiers, things like that, that Rancher relies on as part of these custom resources to operate correctly. Now, with the Rancher backup and restore operator present, we're able to deploy Rancher anywhere. The etcd reliance is gone with this backup operator, and all other Rancher components outside of the custom resources are Kubernetes core or native resources. Things like config maps, secrets, ingresses, that sort of thing can be backed up either by this backup and restore operator or by an independent backup solution. Cloud-hosted Rancher. Let's take some basic considerations into account. With cloud-hosted Rancher, there are four main areas we'll want to discuss: high availability, fault domain spread, ingress, and hardware requirements. When we discuss cloud-hosted Rancher and high availability, this is going to be achieved through running multiple copies of Rancher. This is actually achieved in Kubernetes using the deployment object. Rancher will run as a high availability set by scheduling a deployment with 3 replicas. One is able to schedule more replicas in the deployment and use the targeting options available in a Kubernetes deployment object to spread those replicas across fault domains, which we'll talk about in just a minute. It's important when running multiple copies of Rancher in a cluster to make sure that your load balancing is properly configured. If you're hosting Rancher in a hosted Kubernetes provider, such as EKS, AKS, or GKE, you'll want to configure that hosted provider's load balancing solution to spread traffic into your Kubernetes cluster. In an on-premises deployment, by contrast, this typically takes the form of an external load balancer such as HA Proxy, Nginx, or even an F5 appliance. In an on-premises environment, let's say it's an RKE cluster, we typically spread the traffic from one of those load balancer instances to all of the worker nodes in the cluster, as all of the worker nodes in the cluster will be running an instance of, in an RKE cluster, the Nginx ingress controller. In an RKE cluster, the Nginx ingress controller receives traffic on ports 80 and 443, then processes the ingress rules and forwards the traffic accordingly. In a cloud provider, this is much easier with the abstractions that AWS or Azure make available. So you need only create a load balancer from within your hosted Kubernetes cluster and allow your cloud provider to take care of the rest of the operations. Then, once you have your load balancer domain name provisioned, set that up in your DNS provider of choice for rancher.mycompany.org, forward your traffic accordingly, and now you've got high availability access to your Rancher environment. When it comes to fault domain spread in cloud-hosted Rancher, we want to take care in on-premises to ensure the following things are accounted for. So for on-premises, we'll want to ensure that power circuits, racks, perhaps cooling units, or even compute clusters are taken into account. In an RKE cluster, this takes the form of adding multiple nodes and then adding labels or annotations to those nodes. It would actually be labels to determine what fault domains these nodes belong into. An example of a label could be power circuit A, power circuit B, cooling unit A, maybe rack ABC, 1, 2, 3, so on and so forth. Then we apply the concepts from high availability in the previous slide to spread out the replicas of the Rancher instance across the on-premises fault domains. In cloud hosting, this is a much simpler operation. Cloud, in most instances, has abstracted away the idea of a fault domain to a single item called an availability zone. If we use AWS, for example, this is going to be something like US West 1A, 1B, 1C, or pick your favorite AWS region. You'll want to take into account those availability zones, and most Kubernetes hosted distributions do this for you by adding labels to indicate which availability zone those nodes are running in. Then, when you configure your deployment for Rancher, you can spread those nodes using affinity or anti-affinity, or even label scheduling rules to ensure that replicas of the Rancher instances do not end up in the same availability zone as another replica. When it comes to cloud-hosted Rancher with regard to ingress, we need some advanced configuration to do with our cloud providers. On RKE, RKE2, and K3S, there is an ingress controller that comes installed along with the distribution of Kubernetes. For RKE, it's the Nginx ingress controller. For K3S, it's the traffic ingress controller. But all of these things come installed out of the box, running RKE up, RKE2 install, or the K3S server or agent brings those ingress controllers along with. In a cloud provider, the landscape's a bit different. Typically, there is not an ingress controller installed in a hosted Kubernetes cluster. In the example of EKS, there certainly isn't, and so we would need to install an Nginx ingress controller or traffic or a HA proxy or F5 or any of the ingress controllers that are out there. So you'll want to make sure you install that according to provider-specific instructions, but it is a DIY process. You will be responsible for the life cycle of the ingress controller, making sure it remains up to date, and any changes are applied in a satisfactory manner. In cloud-hosted Rancher, there are specific hardware requirements. This is also true of on-premises Rancher, but we can separate these out into specific resources like CPU, memory, disk, or in the cloud provider world, into instance sizing. When we're talking in an on-premises Rancher installation, we're looking at a minimum of 2 CPU, 8 gig of RAM, and then a fast disk with enough space for images plus logs for the Rancher installation. I don't have a hard recommendation here other than to say somewhere around 50 gigabytes is a good starting place. You want to make sure with on-premises Kubernetes clusters that you have fast enough disk. This is critical because etcd is a file system IO dependent resource, and it will persist all changes to the etcd database to the file system before confirming the write into the etcd data store. If you don't have fast disk, you're going to quickly be backed up by IO onto your disks, and etcd will suffer as a result. So make sure your disks are fast enough, usually SSD. Maybe you can get away with 10 or 15K SAS in the data center, but make sure there's high IOPS there. When we talk about cloud providers, we generally don't have to worry about that as much unless you're starting to schedule HDD type of storage resources. In most cases, you'll be scheduling SSD resources, which are going to be fast enough for hosting etcd. When we talk about CPU and memory requirements, we can talk about these specifically in terms of instance sizing. For AWS, and in that case, EKS for a hosted Kubernetes solution, you'll want to use a T2.large instance. You can get away with T2.mediums in small situations, but a lot of the day 2 tooling that Rancher adds to the Kubernetes experience will not run on T2.mediums. For example, monitoring tools such as Prometheus and Grafana are going to require more CPU and memory utilization than will be available on a cluster full of T2.mediums. T2.large then is a pretty good default recommendation, and of course you can increase from there based on the requirements you have. For GCP, and this would be the GKE hosted Kubernetes provider, we're looking at E2-standard-2 instances. In Azure or an AKS hosted provider, we're looking at standard D2 instances of either the V1, V2, or V3 series. This concludes the presentation on hosted Kubernetes on AKS, EKS, and GKE. If you have any questions about this presentation, comments, concerns, or otherwise, please feel free to reach out to me. My email address is eamon.bauman@suse.com. I'd love to hear any questions, comments, concerns that you have. Thank you very much.